At how to solve homogeneous first order differential equation. And the first step is to change the the equation, change the equation to the form the y dx equal to f over y over x, or f over x over. So change that differential equation to this form. Okay. Then the second step will be to suppose suppose um, y equal to vx. Okay. Or v equal to y over x. So what we mean by this is this. You are substituting y over x. You have v, you have anywhere you see y over x, that will be v. So in that case, now that will call for change of variable of the given differential equation. So you substitute for y over x, or this one. Okay. So if you are using this one, that will be inverse of that. Okay. So suppose y equal to vx, and if you make v here, then you have y over x. Suppose y is that, and that will call for what? And that will change, and that will change. The differential equation to a new variable, in form of v and x. So let's do that. If you are substituting y for vx, y equal to vx. Okay. So then the y, the x will be equal to, if you keep this constant and you differentiate this, you have what? You have v. Then plus what? Take s constant and differentiate v. That will be v dx. Okay? And that will be equal to your dy dx. Your dy dx will be equal to f of v, and already you've changed the variable to v in form of v and x. Then your dy dx, you just substitute this for that, and that will be v plus v plus x, the v dx equal to what? F of v, and that will give you an expression. That will give you an expression. Okay, so that's that. And don't forget that these variables, they're both a function. So that's that. So let's go to question solving. We have this. Solve the first order differential equation equal to this. Okay. And what I skipped to mention on how to solve homogeneous first order differential equation. After you have changed the variable to the form of v and x, then the next thing is to use the method in first order differential equation, and that will be separation of variable. Okay, and then you integrate. Okay, let's take this one straight away. So this is what we have here. Solution to this question. So how can we have y over x in this place? So solution, the y dx will be equal to, let's divide through by that denominator here. So it will be to be equal to 1 here, s squared over x, s squared over s squared, then plus this one over s squared. So then will be y over what? Over x, then plus this will be y over x or squared. That is y squared over s squared. And already the denominator has gone. So we can see now we now have the y dx as a function of this fraction. So now what do we do next? Let's what? Suppose y equal to vx, okay, which is same thing as what? V is equal to y over x. So let's differentiate that. If you differentiate this respect to x, so the y dx v equal to, differentiate your x, while you keep v constant, then plus, you keep s constant and differentiate the v with respect to, that's the v dx. Each of them are both functions of x. So that's what we have there for dy dx. Then the next thing to do is to change the variable. Change the variable. Your dy dx, we have the new expression for that, which is a v plus what? Plus x. Okay, the v dx equal to 1 plus. Don't forget that this one is now function of v now. Okay, anywhere you say this, that's y over x. We are using substitution for that. That is v. Okay, so that will be equal to 1 plus v and then plus v squared. Okay, something will cancel out there. V is there. V is there. So I have x the v dx equal to 1 plus v squared. So in this case now, the only what we can do now is to separate the variable. So since it's possible that the next technique is just separation of variable. So what can we do? This one can go to other side. So divide both sides by that, by 1 plus b squared. That will be 1 over 1 plus b squared. And left the function, okay, the v. Then remove this x from here. That's 1 over x. Okay, I'm dividing both sides by what? By x. So that goes, and then multiply through by what? The both sides by this denominator, and that what? Dx. So we have separated the variable. Then the next thing to do is to integrate both sides. Okay, and if you integrate both sides, we know that integral of 1 over 1 plus b squared will give us arctan b, okay, equal to ln what? Ln x, and then plus the constants. Okay, so of the integration. So what next now? What next is to replace this v back, because v was not part of the question. You see any v here? It wasn't part of the question. Return it back, which is arctan. Your v is y over x equal to ln x plus c. Then the next thing to do is to try to remove, I want to try to see if you can make y the subject of the equation. Take tan of both sides, and that will be y over x. When you take tan of arctan, it will just give you the function, and that will be equal to what? Tan ln x plus c. Then you can multiply both sides by the denominator, okay, of this of the left hand side. So y is equal to what? X tan ln x plus c, and that's that for that problem. Okay, that's that for that problem. Okay, so when you look at it, you see that this is first order differential equation. Okay, so the next thing you can do is just to find a way to make it y over x. Question we have, question 2, solve the first order differential equation. You have that. Okay. So what do? At the beginning, you can't separate the variable. You can't separate the variable, but they'll just tell you solve. Okay. If you want to separate variable, it must be of this form. We've explained that before, and it's not yet now. Okay, so if you look at it now, you can just go on your dy dx. Let's divide by that 2. Divide each item by 2x. Actually, algebraically, this means 2y over 2x plus this one over 2x, algebraically. So that's the limit. I think I should start from there. 2y over 2x, then plus this x squared minus y squared over 2x. So, and this will give me y over x, then plus a half here. Okay, then I can turn this one, I can expand this radical, and that will be equal to x squared minus y squared all over x squared. You know, square root of x squared is what? Is x. So it's x. So and don't forget that if you have a square root of a fraction, it implies square root of the numerator and denominator. So that's just that. It does not change the form of that of that variable. So this is what we have now. What can we do now? This will give me y over x plus half, and then square root. This will be 1, this one over this one, 1 minus y over x or square. So that's dy dx. And you can see now that the y dx now is now of the form of this. It's now of this form. Okay? So what we just do is just for us to do the substitution, do the normal substitutions. Okay? So that will be equal to y equal to vx. Okay? And also v is y over x. So my dy dx now of this, suppose, of these substitutions will be v plus x dv dx. It's a product rule. Use the product rule. Okay. They're both functions of x. X is a function of x, and this one is also its own function. So that's what we have now. Then we can go back. Just note this one. Go back to the problem. So the y dx 1 is equal to f of what? F of v. Okay. So with that now, we can now have v y over x v plus half square root of 1 plus v 1 minus v squared square roots square roots 1 minus v squared. Okay, so then we have an expression for dy dx which will be v plus x dv dx equal to v plus half square root of 1 minus v squared. This one and this one we cancel. Then we have x dv dx equal to half square root of 1 minus v squared. Then we can separate the variable. I think we can move this one to the other side, which will be equal to 1 over 1 minus v squared, that's square root dv, then equal to, divide both sides by this, that's 1 over x. Okay, that'll be half times 1 over x, then multiply both sides by dx. So that's that. Then you can separate both sides. We've done the separation. We separated the variable now. We've separated now the variable. Then the next thing is to take the integral of both sides. And this constant can go outside the integration. Then I have this. And then don't forget the integral of this function, 1 over square root of 1 minus v squared is inverse of arc sine, inverse of sine of this function of v. It's just a table, okay? It's a table. And this will be equal to half ln x plus c. Okay? Then we can, since v is not part of the question originally, so we can begin to substitute v back. V is what? Y over x equal to half ln x plus c. Then we can remove this inverse here by taking sine on both sides. If you take sine of arc sine, it will just give you the function here. Okay, take sine of both sides. Then you have y over x equal to sine half ln x plus c. Okay, then multiply both sides by the denominator here. So y is equal to x sine. So that's what we have now for this for the question. So that's what we have for the question. And if you want to go further, it could be the answer could be of this form. This half can come here on top of this function, and that will be ln with x plus c. Okay, so that's that on that question. So this is what we have. We have this question: solve x squared exponential to power x plus y squared dx. So what you do and this is a signal for you of what to do. Okay, so what we do is for us to divide the equation, divide through by this xy. Okay, that xy. So we now have we have um, we have then maybe first thing we can do first, we do that, and at the same time, this one we remove it from here. Okay, so therefore we can have the y and the x. So that's the first thing. Divide both sides by what? By dx. Okay, so the x will go here to come here, and at the same time also divide by what? Xy. Okay, and that will be equal to x squared this plus y squared all over xy. Okay, and that will be equal to this one and this one will go. So I will have x over y e. Okay, then plus y also will go. That will be y over x. Okay, so we can write now the y dx is equal to this one. I want to make it to be like this also, so I'll just try to put inverse on it. I've not done anything. It's still the same expression. I'll just put one on top of that. If I put and I will reverse, as I'm putting one on top of it, I have to reverse this fraction. I will not call it y over x. Okay, it's still the same thing. E takes plus what? Y over x. So this one is now equal to what? F of what? Y over x, which is what? Homogeneous. This is homogeneous. So the moment you can express your dy dx in this form, then the equation becomes homogeneous. Okay. Then the next thing to do is force to use the substitution. Let y be equal to vx. This one, v is equal to what? Y over x. Okay. Differentiate this. The y dx is equal to v plus what? X dv dx. Product through. Okay. Then change the variable now. Change the variable. Your dy dx is this expression. So anywhere you see dy dx, just put this one there. V plus x1 equal to this will be what? 1 over what? 1 over v. 1 over v e minus v plus v plus v. So this one will go, this v here, and this here will go. Okay. Yeah, I will now have 1 over v. So if you like, you can this could be 1 over v. This minus here is 1 over. So and that will be 1 over v e ev. Okay, plus okay, that one has gone. So we can v dx. We can separate the variable now. So by multiplying through by this denominator here, and that will be equal to v e dx dv, and at the same time also divide both sides by x and divide 1 over x. Multiply both sides by what? By dx. So you have this. Okay. So the question now is, how do we differentiate now this product, this expression? How do we differentiate that? Okay. What I will do now, how to differentiate this? This is a product. Okay. We can use change of variable here. I think this one is like 2v, like v square. We'll have substituted for what? For this one, but it won't work for this. So what we do now is to use integration by parts. Integration by parts for the left hand side. So I'm going to call the first one u is equal to v. So the u is equal to what? The v. The second one, I'm going to call it w, because normally I should have called it dv, but it's going to create a confusion because the function is in v. So I have to change it to the w is equal to what? Is equal to ev dv. Okay. So I hope you get what I mean. If I call this one for the normal thing, integration by parts in the previous video, been using uv equal to what? Integral of v du. If you remember, if you watch the video, okay. So if I now call this one v now, I make this second one the v, and I call it the v, it creates a confusion. The v equal to this, because this one already is in the form of v. So let's give it another name, dw equal to this. Okay. Integrate both sides. W is equal to what? Is equal to e ev. So then I'm having now u multiply this one, uv, uw, that's v ev minus integral of w ev du. Du is what? dv. Okay, and that will be equal to v ev minus integral of this one, that's this. So I've gotten the integration by parts, which is what? V e ev minus this equal to ln x, ln x plus c. So that's that. So, but that's not the end of the question. We need to return the variable back. V wasn't originally in the question, so we have to. V is equal to what? Y over x. E y over what? Y over x minus what? E y over what? Y over x equal to ln what? Ln x plus c. Okay, so that's what we can do in this case. Another thing we can do, we can factorize here. We can factorize this one out, and that will be equal to what? There's no need. We'll just leave it that way, so that will not. There's no need. So this is the solution. This is the solution of the differential equation, of the first order differential equation of the what? Of the how will I call it now? Of the differential equation. Okay, that's the solution of the differential equation. So that's that on this.